In this question, we have to determine the y parameters of the network. Okay, we will be making use of the mesh analysis to determine the impedance matrix, and from there we will determine the y parameters. Okay, let us first consider the currents in each of these loops. This is, let us say, this is I1, this is I2, and this as I3. Okay, now we will write the equations, okay, corresponding to the mesh analysis. So 1 plus 1 by s, okay, 1 plus 1 by s because we have 1 ohm resistor and 1 by s capacitor with impedance 1 by s. Okay, so we will get 1 plus 1 by s, and for I2 in the first equation, when corresponding to V1, we will get minus 1. Similarly for I3 we will get minus 1 by s. So we must be familiar with this at this stage. Okay, minus 1 minus 1 by s, minus 1 1 plus 1 by s minus 1 by s, minus 1 by s minus 1 by s, 2 plus 2 by s into I1, I2, I3 is equal to V1 minus V2 0. Okay, now the first step here is to determine del 1 okay, del 1 is the determinant of, in fact it is a cofactor of the first element, okay, which is 1 plus 1 by s. To find that, we have to find the determinant of the resulting matrix that we get by eliminating the first row and first column. Okay, so it will be the determinant of this particular matrix. Okay, that when we determine, it will be equal to 2 plus 4 by s plus 1 by s square. Now if we observe for del 2 also, okay, by removing this column and this row, we get the same set of elements, which implies that the determinant of that matrix is also the same. So for del 2 also it is same. Okay, now for del 1 2, okay, del 1 2, what we have to do is we have to remove the first I mean this particular column, and sorry, we have to remove this particular column, this particular row and this particular column. Okay, from the resulting matrix we have to find its determinant. But one thing that we have to keep in our mind is, while calculating the cofactor, we have to multiply it with a negative sign, okay, to the power of 1 plus 2 here. Since we get no, to the power of 2, negative sign to the power of 2 is positive, so we omitted in the previous case, but in the next case we have to consider that. So considering that and then determining the determinant of the resulting matrix, we get del 1 2 is equal to 2 by s plus 1 by s square, which is again equal to del 2 1. Okay, now we have to determine y11. So y11 will be equal to del 11 by del, so that will be equal to 1 plus 4s plus 2s square divided by 2 into 1 plus 2s. So this is also equal to y22, because del 22 is equal to del 11, and hence del 22 by del will also be equal to del 11 by del. Okay, similarly y12 is equal to del 12 divided by del is equal to 1 plus 2s plus 2s square divided by 2 into 1 plus 2s, and again this will be equal to y12. So the correct option is D. See, generally what we will do is, if we have a simple circuit, we can consider the two cases where V1 is equal to 0, and then in the next case where V2 equal to 0, and then determine y11 and y22, which is not easy in this case. That is why we go for a different treatment like this.